Hi, Assalamualaikum and good morning. Today we will present about introduction semiconductor components and its operation. Course code DJM 20042. Course name Electronic Systems. Assessment Presentation for Practical Task. Lecturer's name Sir Tan Po Chua. Our group members have three. First, Nur Aisyah Hamiza binti Salahuddin, her metric number 01 DEM 21F 2002, and me, Wan Nur Alia Syafiqah binti Wan Syukri, my metric number 01 DEM 31F 2009, and the last person is Nantini Dewi, her metric number 01 DEM 21F 2005. Next, table of content. First, we have introduction. Second, semiconductor component, which is diode. Third, principal operation of semiconductor diode. Fourth, example application of diode. Second last is conclusion, and lastly is reference. Introduction for semiconductor. Semiconductor are materials with conductivity intermediate between conductors, typically metals, and non-conductors or insulators such as most ceramic. Semiconductor can be pure elements like silicon or germanium, or they can be compounds like gallium arsenide or cadmium selenide. Silicon is the best and most widely used semiconductor. Small amount of impurities are added to pure semiconductors in a process known as doping, causing large change in the material's conductivity. Aside from doping, increasing the temperature of semiconductor can improve its conductivity. This is in contrast to how metals behave, where conductivity decreases as temperature rises. Doping increases the number of charge carriers in the crystal significantly. A doped semiconductor is referred to as p-type and when it contains free holes, and m-type when it contains free electrons. To control the concentration and regions of p and n-type dopants, semiconductor materials used in electronic devices are doped under precise conditions. A single semiconductor device crystal can have many p and n-type regions. The useful electronic behavior is caused by the p-n junction between these regions. Next, diodes are one of the semiconductors. A diode is a semiconductor device that functions as a one-way current switch. It allows currents to flow freely in one direction while severely limiting current flow in the opposite direction, because they convert alternating current AC to pulsating direct current DC. Diodes are also known as rectifiers DC. Diodes are classified based on their type, voltage, and current capacity. P-type and N-type diodes are formed by combining these two materials. Electron and holes will combine in the joint region, resulting in a lack of carriers in the region near the junction depletion region. Diodes semiconductor material compose a half P region and half N region, doped regions with a p-n junction in between. The p-type region is known as the anode, while the n-type region is known as the cathode. As we can see, semiconductor diode construction, anode in the side of P, cathode in the side of N, and depletion region in between the P and N. As we can see, diodes are available in various configurations. From left is metal case, stud mount, plastic case with band, plastic case with chamfer, and glass case. When a diode allows current flow, it is a forward bias. When a diode is reverse bias, it acts as an insulator and does not permit current to flow.
What is a semiconductor diode? A semiconductor diode is a PN junction diode. It is a two-terminal device that conducts current only in one direction. The figure below represents the symbol for the PN junction diode, which symbolizes the direction of the current. By applying an external voltage, we can vary the potential barrier. When we apply the external voltage across the semiconductor diode in such a way that the P side is connected to the positive terminal of the battery and the N side is connected to the negative terminal, then the semiconductor diode is said to be forward biased. In this case, the built-in potential of the diode and thus the width of the depletion region decreases and the height of the barrier gets reduced. The overall barrier voltage in this case comes out to be V0 minus V, which is the difference between the built-in potential and the applied potential. As we supply a small amount of voltage, the reduction in the barrier voltage from the above given formula is very less, and thus only a small number of current carriers cross the junction in this case. Whereas, if the potential is increased by a significant value, the reduction in the barrier height will be more, thus allowing the passage of more number of carriers. When we apply the external voltage across the semiconductor diode in such a way that the positive terminal of the battery is connected to its N side and the negative terminal of the battery is connected to the P side of the diode, then it is said to be in the condition of reverse bias. When an external voltage is applied across the diode, as the direction of the external voltage is the same as that of the barrier potential, the total voltage barrier sums up to be V0 plus V. Also, the width of the depletion region increases. As a result of this, the motion of carriers from one side of the junction to another decreases significantly.
Diode applications, rectifier circuits. As we mentioned under rectifier diodes, the most common usage of diodes is the rectification of AC to DC power. Constructing rectifier circuits, they are used in half-wave and full-wave rectifiers. In typical power conversion applications, a single or a combination of 4 diodes are used. For reverse current protection, in case the user reversed the polarity of the DC power or connected the battery wrongly, where a large amount of current is surging through the circuit, a protective diode can be connected in series to prevent the reverse connection issue. Conclusion. It can be concluded that diode acts only when forward biased. Operation of diode can be summarized in form of IV diode characteristics graph. For reverse bias diode, where V equals to supply voltage, ID is equal to diode current, IS is equals to reverse saturation current. Initially, its internal resistance, both forward and bias, can be observed. Then by experimenting voltage and current change, the relationship also can be defined. Finally, the behavior of half-wave rectifier also can be analyzed with the help of oscilloscope.